Hello guys, among the tools we need for our DIY journey is a digital multimeter. So this is a meter. It's used for so many, you can use a meter for so many things. This is what a digital multimeter looks like, and this is the probe. So in this video, I'll be showing us different things you can do with this multimeter. First of all, you can use the meter to test for voltage, to confirm if there is voltage in a particular point. So it will show you that yes, there is voltage, and it will equally tell you the value of voltage. So you can use it to test for continuity at different points to know if a wire is through or it has a breakage. You make use of your multimeter for this purpose. And first of all, let's test for voltage. Mind you, there are two types of voltage. We have the AC voltage and the DC voltage. AC voltage is the alternating current type of voltage you find from sources like this and a wall socket. Then DC voltage is the kind of voltage you find from batteries or rectifiers, or you can call it charger like this. Okay, so first of all, let's test for AC voltage using our digital multimeter. I'm going to power this extension on from the socket. Good. So this is how to do this, guys. This is my probe. So I'm going to connect. You can see a point written common. The black probe goes to the common, while the red probe comes here. Now we are going to test. So before we go forward, I'm going to set this multimeter to AC voltage. This is the sign for AC, alternating voltage. I will bring it to the maximum value on the AC section, AC voltage section. So the maximum value I have here is 750. Okay, so 750. Then the next thing I will do is to take these two probes and place them at the circuit points. You can see it's giving us 197 volts, about 198 volts or thereabout. I hope you can see this clearly. Okay, it's up to 200 now. So we have approximately 200 volts AC. All right, so the next we are going to test now is for DC. So DC, I will equally set this. This is the sign for DC. I hope you can see this clearly. So I will set it at the maximum voltage on the DC range, which is 1000. So it's either I do it that way, or I check what I'm going to test. This is a laptop charger. The input is AC while the output is DC. Now let us see the maximum output voltage. The maximum output voltage is 19 volts DC. Already when I was testing the AC, I know the range of voltage I was expecting 200 and above. So I had to set it above 200. I set it at 750. So in this case, I'm testing for 19 volts DC. Output DC 19 volts. So I can set my voltmeter to 200. But I wouldn't want to set it at 20 because it's too close to 19. So once I've set this to 200 volts DC, the next thing I will do is to plug this charger. I've plugged it here. All right, so the input is AC. Then the output here is DC. It's the same type of electricity you obtain from a battery. Okay, so now to test the value of DC voltage from this charger, you put the positive probe inside. All right, then the negative probe comes at the body like this. So you can see the value of DC voltage you are obtaining from this charger, 19.4 volts. All right, it's rated 19 volts because we are getting 19.3 or 19.4 volts thereabout. Okay, so what we just tested now is for DC voltage. Okay, so another important thing you can use your multimeter to test is continuity. So to test for continuity, look at this point here. I will set my probe to continuity. Good. So we test for continuity on cables. I've detached this cable from the extension from the power supply. So if you want to test a cable for continuity, I've set my multimeter to continuity. You see this point with a boost. Then I will place one probe here, and then I will place one probe in these terminals. There is no continuity on this terminal. but there is continuity on this terminal. So there is no internal breakage in this wire. So let me test this other side. I'll place one probe here. Please remember, as I'm testing continuity, it is not powered, it is not plugged in. So I will test for this probe. Good, there is continuity. So this plug has no breakage whatsoever. So another place you can test for continuity is on something like a fuse. This is a fuse. You set your meter to continuity to test if a fuse is okay. Good, as you can see, we have continuity readings for this fuse. Another place you can test for continuity is a switch. Okay, a switch or a circuit breaker, when it's in the on state, should give you continuity reading at the 2 terminals. So there is no continuity here. So let me switch this on and see if we get some continuity reading. Good, as you can see, we have continuity reading. If it's off, there's no continuity reading. So if a switch is in order, there should be continuity between the supply point and the place it is switching. All right, the supply point and the point it is switching, there should be continuity reading. So these are some of the important things that we can do with our switch. So when you hear test for voltage, your mind should go to what type of voltage am I testing? Is it AC or DC? If you identify the type of the voltage you are going to read, you now set your meter to the particular value you are expecting. So like this extension now, before I can test for voltage on this extension, you can read what we have here. First of all, it is 220 to 240 volts. I already know that from a wall socket, I'm getting AC type of electricity. So I already have in mind that I'm going to test for maximum of 240 volts AC. So on my meter, I don't have 240. The next highest value I have is 750. So it is safe I place it at 750. Okay, so that is how to test for voltage, test for continuity using a multimeter. So if it's DC you are going to test, you read the load to know the value of DC you are expecting from the terminal you are trying to test. So in this case, what we have is output DC output 19 volts. So you already know you are testing for DC and you now know the value. So the next thing to do is to set your multimeter to the perfect range. If you set it to 20, it's too close to 19, so the safest is placing it at 200. Then you observe the polarity. You observe polarity when testing for DC loads, red to the positive, black to the negative. Okay, so but if it's AC load like this, like what we have from a socket, if I place my meter to 750, either I follow this order or I follow this order. I hope you can see this clearly. No matter how I place my probe, whether this way or this way, it is still going to give me the same value. But if you do that for the DC, if you place red on the positive, on the negative, and black on the positive, you're going to get a negative sign. All right, let's do this quickly. Let's test this quickly so that we understand what I am talking about. So I'm going to plug this right here. Watch this. This is what we did the first time, red to red and black to black, and it gave us 19.4. So if I change the polarity now, let's see what's going to happen. I've taken this black to where the positive is meant to be, and then I brought this red here. You see, it gave us a negative sign. There's a negative sign implying that we crossed the polarity of the probe. So the correct order for testing DC loads, because it obeys polarity, is positive to positive, negative to negative. It gives us our accurate value without any negative sign. Thank you guys.